Hello.
Good evening, sir.
Yeah. Good evening. Okay, we are going to do some questions on complex numbers. Um, this is the first one. We'll revise the theory through the questions.
Okay, sir.
Tell me if you understand this notation. What is the meaning of this thing?
Sir, real part of Z minus conjugate of Z
Yeah, real
plus,
part of this thing
yes, sir.
is an element of the set such that this condition has to be satisfied, where Z is a complex number and real part of Z is 3, right?
Yes, sir. Yes, sir.
So the elements of the set will be what? Elements of the set will be possible values of this, right?
Yes, sir.
This symbol here means such that, okay?
Yes, sir.
So the set is set of all of this such that Z is complex and real part of Z is 3, right? Correct, no?
Yes, sir. Sir,
Hmm.
the set of all values which will satisfy this relation, real part of Z equals to 3.
Set of all the values of this thing for which real part of Z was 3, right?
अच्छा.
Matlab Z, if Z is A plus BI, Z is actually what? 3 plus BI, right?
Yes, sir.
Because they have given us that real part of Z is 3, right?
Hmm.
Now you have to calculate if Z was 3 plus BI, then what are the possible values of this, right?
अच्छा.
Do you understand what I'm saying?
Yes, sir.
Whatever is possible values of this will be part of the set.
Yes, sir.
Basically, if I say set of X such that X square is less than 4, then this is the condition. And for all X such that X square is less than 4, those values are part of the set, right?
Yes, sir.
Do you understand?
Yes, sir, I do.
Okay, so the question is saying this is the situation, and if the set is equal to the interval, so apparently you have to calculate the set basically for possible values of the set. The set is equal to this interval. So then once we know the interval, then we can find the answer. So in order to do that, let's think of Z as a complex number X plus Iy, right?
Yes, sir.
Now we know that X is equal to 3. We'll put that later. We know X is equal to 3, but we'll
Yes.
simplify this first. So real part of Z minus Z conjugate. So X plus Iy minus X minus Iy. Z times Z conjugate is mod Z square. You know that, right?
Yes, sir.
Z into Z conjugate is mod Z square, and mod Z square is X square plus Y square. Okay, divided by 2 minus 3Z, so that is 3X minus 3Iy plus 5Z conjugate, so plus 5X minus 5Iy, right? Correct?
Yes.
So the
सर
thing,
साइन नहीं होगा यहाँ पर 2 - 3y में.
yeah,
2 - 3z में आपने क्या है, ये साइन चेंज नहीं होगा यहाँ पर.
तो कर तो दिया साइन चेंज.
अच्छा अच्छा, सॉरी सॉरी सॉरी. हाँ, वो माइनस हो गया.
हाँ. So when we simplify now here, it becomes what? Top part, this gets cancelled. You get, okay, 1 second. It gets added actually. It doesn't get cancelled. X gets cancelled. It becomes 2iy. It becomes top part is x square plus y square plus 2iy, right?
यस सर.
And denominator is minus 3x plus 5x. So it is 2 plus 2x minus 8iy, right?
यस सर.
So anytime you have a fraction type of situation and both numerator and denominator are complex numbers, the way to simplify it is by multiplying with the conjugate of the denominator, right?
Yes, sir.
ये सब पता है ना?
Yes, sir.
a plus ib by c plus id कैसे सिंप्लीफाई करेंगे? we'll multiply by c minus id up and down, right?
Yes, sir.
So I want the real part of this complex number inside the bracket, but it is in a fraction sort of situation. So first I have to simplify that. So I'll say x square plus y square plus 2iy by 2 plus 2x minus 8iy. I will multiply it with the conjugate of this is 2 plus 2x plus 8iy divided by 2 plus 2x plus 8iy, right?
Yes, sir.
Denominator will become now perfect square, which is the modulus of this complex number. So it will become 2 plus 2x whole square plus 64y square, right? Because you
Yes,
are
sir.
doing a minus b into a plus b, so it is a square minus b square, and I square becomes minus 1.
Yes, sir.
Numerator, we have to actually calculate. You will get x square plus y square into 2 plus 2x. Then you will get one term which will come when you multiply this item and this item. It will become 16y square minus, so minus 16y square, right? And the
Yes,
other
sir.
two terms will have I, right? The other two terms will be when I multiply this x square plus y square with 8iy and when I multiply 2iy with 2 plus 2x, right?
Yes, sir.
So I don't care about that because I know need only real part of this complex number, right?
Yes, sir.
This is the imaginary part. I don't even want to multiply it. So I will just say that the real part of this complex number is basically x square plus y square, 2 plus 2x minus 16y square divided by 2 plus 2x whole square plus 64y square, right? Correct?
Yes, sir.
This is the real part we have calculated now. Now we'll also put the condition that x is equal to 3 because real part of z was 3, right?
Yes,
So
sir.
we'll simplify it further. X का value पता है तो डाल देंगे वो. It will become 9 plus y square and here it will become 6 plus 2 8 minus 16y square divided by this will become 3 6 8 8 square 64 plus 64y square, right?
Yes, sir.
So this becomes 72 minus 8y square divided by 64 plus 64y square, right?
Yes, sir.
8 will get cancelled and now you will get after that 8 will get cancelled, you will have 9 minus y square on top and 8 plus 8y square on the bottom, right?
Yes, sir.
This is my set. This is the elements of the set, no? All the possible elements of the set, right?
Yes, sir.
Here y could be any real number because z was what? Z was 3 plus iy where y was real, right?
Yes, sir.
There was no other restriction on y. So y can be any real number. So the possible values of this set will be like range of this function, right? This is like a function of y now, right?
Yes, sir.
The possible values of this set, what are the possible values of the set? Which will be the possible values that this expression will take when you put y as anything, right?
Yes, sir.
If you take f of y as 9 minus y square by 8, 1 plus y square, we have to figure out the possible values of this set. So the general way to do range of quadratic type of functions, this function can be written as f of x is equal to 9 minus x square by 8 times 1 plus x square. How do you generally take range of such functions? You can try doing calculus, but if it is a quadratic by quadratic, there is an algebra method to find range. Do you know that?
No, sir. Sir, we have to make cases, I guess.
No,
Like when
you don't have to
the
make
no.
any cases. See, if the function is like this, you don't know how to calculate range of this function. Suppose it was like this.
Mm,
Do you know the meaning of range?
Yes, sir. What possible values f
Hmm.
of y will give?
What possible values can this expression take, right?
Hmm. No, sir, that is domain,
तुम
I
मुझे
guess.
तुम मुझे बता रहे हो, ऐसा लगता है कि मुझे पता नहीं है डोमेन रेंज।
Sorry, sir, I'm so sorry, but what value it can take is a domain, I guess, and what output is range.
वही तो मैं बोल रहा हूँ, व्हाट इज द पॉसिबल आउटपुट्स ऑफ दिस एक्सप्रेशन।
Sorry, sir. Okay, sir.
सॉरी के लिए नहीं बोल रहा हूँ, समझ लो क्या बोल रहा हूँ।
Okay, sir.
द इनपुट x values is domain, but how will you
And
find the possible y values? क्या करोगे उसके लिए? उसके लिए इस एक्सप्रेशन का पॉसिबल आउटपुट ही ना निकालना है।
yes, sir.
वही तो बोल रहा हूँ कि इस एक्सप्रेशन का पॉसिबल आउटपुट होना चाहिए, जो भी आउटपुट आएगा।
Yes, sir.
The way to find if there is a quadratic by quadratic like this, here also
Hmm.
there is a quadratic by quadratic.
Hmm.
There is a calculus way to find range. The calculus way to find range is to try to think of maxima or minima of this function. However, there
Hmm.
is a algebra way to find range also. The algebra way is to say that, okay, I will multiply the denominator, bring it here. I will say y times px square plus qx plus r is equal to ax square plus bx plus c. And
Hmm.
what is the purpose of doing this? I can convert it to a quadratic in x. For example, here you can easily rearrange the terms and write py minus ax square plus qy minus bx plus yr minus c equals 0, right?
Hmm.
कुछ समझ में
Yes,
आ
sir.
रहा है क्या हो रहा है?
Yes, sir.
This is the
Y
same
comma
expression,
comes
but
in.
I have made it a quadratic in x, right?
Yes, sir.
Now you can say that since x belongs to real, x will also be real numbers here, obviously. So we can say that this quadratic has real possible x's, roots, real roots, right? So
Hmm.
the discriminant has to be greater than 0, right?
Yes, sir.
Discriminant has to be greater than equal to 0 because the quadratic equation will have real values of x as roots, right?
Yes, sir.
When you do discriminant is greater than 0, you will get a condition involving just the y, because when you calculate discriminant, it will
And
have only y stuff, right?
yes, sir.
Then you will get a condition on just the y, and then from that condition, you can find range of y.
Acha. Yes, sir. Got it.
There are several questions like this in your quadratic equation book, wherever you have done quadratic equations from. You have to go
Sir.
back to that chapter, see the examples. This is a very standard process. Many times IIT has asked questions on this also.
Yes, sir.
For now, we will do it for this particular function. For this function, we are going to try to do the same process. So I want to find the range of this function. So I will say y is equal to 9 minus x square by 8, 1 plus x square. So I'll say 8y 1 plus x square is equal to 9 minus x square. So I'm getting 8y x square plus 8y plus x square minus 9 is 0, right? So
Yes, sir.
this becomes a quadratic x square times 8y plus 1 plus 8y minus 9 equals 0, right?
Yes, sir.
So you are getting, notice that the x term, bx term is not there. The constant term is there, the first term is there, right?
Yes, sir.
This quadratic is very easy to say when x is real. When x is real, your discriminant, notice the discriminant is greater than equal to 0. And discriminant here is simply minus 4ac. So minus 4, a is 8y plus 1, and c is 8y minus 9 is greater than equal to 0. So you get 4 times 8y plus 1 and 9 minus 8y is greater than equal to 0. And that will happen when, see, this will become 0 when minus 1 by 8. and this will become 0 when 9 by 8, right?
Right. Yes, sir.
If y is bigger than 9 by 8, this will be negative and this will be positive. So the whole thing is negative, right? If y is bigger than 9 by 8.
Yes, sir.
If y is between minus 1 by 8 to 9 by 8, this is positive, this is also positive. So this is the portion where it is positive and after that it will be negative. So y का range आ रहा है minus 1 by 8 to 9 by 8, right?
Yes, sir.
So we are getting minus 1 by 8 to 9 by 8 is the range of y, which was our question, alpha, beta. So beta minus alpha क्या आ रहा है? Beta minus alpha is 10 by 8.
8. 5 by 4.
10 by 8 को multiply करना है अब 24 से, right? In the
30.
question they asked 24 times beta minus alpha, which gives us the answer 30. The point
Yes,
of
sir.
this question is it is combining your basic complex numbers and then you have to find range of a function, quadratic by quadratic type of function.
Yes, sir.
So you need to know your algebra properly, otherwise you can't do it. Let's
Yes, sir.
go to the next one. This is let S is equal to Z belongs to complex numbers such that Z conjugate is equal to I times Z square plus real part of Z conjugate. Then you have to find out summation of Z belongs to S mod of Z square. First of all, understand the question, what they are asking. This is again a description of a set, right?
Yes, sir.
This is the description of a set S, where set is a set of complex numbers Z, which satisfy this condition. So obviously, it is not possible for all complex numbers to satisfy this. There might be 3, 4, 5 of them which will satisfy this, right?
That must be purely imaginary.
I'm not talking about conclusions right now.
Yes.
You can do the conclusions and find the answer, but right now we are just trying to understand the question. The set is the set of all complex numbers for which this condition is true, right?
Yes, sir.
If there are 4, 5 complex numbers which satisfy this condition, all of them will be part of this set capital S,
Yes,
right?
sir.
Finally, what do you
Sir,
have to do? Finally, you have to
sir,
find the mod Z square for all of those.
which belongs to S.
All the complex numbers which belong to S, उनका mod Z square करके add करना है, right?
Yes.
So now try doing it.
Sir, can we assume Z as purely imaginary?
वो तुमको समझ में आएगा, तुमसे समझ हो रहा है तब ना करोगे, ऐसे ही जबरदस्ती कैसे assume करोगे?
सर बिकॉज आई है ना Z कॉन्जुगेट में, तो सब कुछ
तो
वो
फिर
नहीं हो जाएगा।
उससे कैसे पता चलेगा? प्योरली इमेजिनरी का क्या मतलब होता है?
सर A इक्वल्स टू 0 अगर A प्लस आई भी है तो।
ए इज इक्वल टू 0, इसको देख के तुमको पता चल गया ए इज इक्वल टू 0 है जेड का?
नहीं सर, हाँ सर, रियल पार्ट भी तो है Z कॉन्जुगेट का।
मतलब इतना कॉम्प्लिकेटेड लुकिंग रिलेशन है, डायरेक्टली कैसे पता चल जा रहा है? मैजिक थोड़े है. If Z is purely imaginary, you can say that Z plus Z conjugate should be 0, or real part of Z is 0. These are the things which will tell you that it is purely imaginary, right?
अच्छा,
Both are the same thing, by the way, just different ways of saying it. Do you understand what I'm saying?
यस सर।
Is it obvious immediately looking at it that this is true, any of these conditions?
नो
It is
सर।
not obvious. You have to do something and see. Maybe it is purely imaginary. Maybe it is not. I don't know. But it is not clearly obvious from here.
ओके सर।
Sir, is it 3 by 2?
No. The final answer you are saying, right?
Yes, sir.
Final answer is not 3 by 2.
Sir, I think there are three elements. One I got 0, another one I got I, and another one I got minus half plus half I.
You have made a mistake in the third element.
Oh,
0 and I are correct, but after that it's wrong.
yes.
We can do it in multiple ways. Simplest way would be just take z as x plus iy. Z conjugate will be x minus iy equal to I times z square will be x square minus y square plus 2i xy plus real part of z conjugate would be simply x, right? You are getting I times x square minus y square plus x plus 2i square, so minus 2xy is equal to x minus iy, right? You end up getting x plus 2xy minus I x square minus y square plus x plus y equals 0. Is everyone getting this equation? I hope you are getting this equation.
Yes, sir.
यस सर, वो सर मेरी क्वेश्चन में साइन थोड़ा गड़बड़ है
क्या साइन गड़बड़?
सर। एक्स -2xy आ रहा है मेरा, शायद कोई मिस्टेक है।
माइनस 2xy नहीं आएगा यहाँ पे, 2i xy इंटू आई हो गया 2i स्क्वायर xy ना, तो
हम्म।
माइनस 2xy तो इधर ही है।
अच्छा, हाँ हाँ, ठीक है सर, आगे।
ये सब केयरलेस मिस्टेक्स अलाउड नहीं है। This complex number is equal to 0 means both the real part and the imaginary part will be 0, and x square minus y square plus x plus y equal to 0. This means first one is x into 1 plus 2y equals 0. So there are two options for first one. Case 1 is when x is 0. Case 1 is x is 0. If you put x is 0 here, you will get minus y square plus y is 0. So y could be 0 or 1, right? Correct. So case 1 gives you two complex numbers. X is 0, y is 0. So there is a 0 complex number or 0 plus 1i, which is I. Now case 2 is when x is not 0. Case 2 is when y is equal to minus half, right? I hope everyone is understanding what I'm saying.
Yes, sir.
Sir.
केस 2 है जब ये वाला 0 है, 1 + 2y is 0, so y is equal to -½ and then in that case we'll put -½ in this equation and we'll get x² minus 1/4 plus x minus ½ is equal to 0. You get x² plus x minus 3/4 equals 0. And so from here we can solve by quadratic formula and you get -1 plus minus root over 1 minus minus plus 1 plus 3, 4/2. So this -1 plus minus 2/2. So it is either -3/2 or 1/2. This is the x and y is anyway -½ So the complex numbers that are coming from here are -3/2 minus ½ I and 1/2 minus ½ I. Is it clear to everyone what we are doing?
Yes, sir.
It is a pretty easy question. You just have to find these 4 complex numbers. And then when you add the modulus of each of those complex numbers, modulus square. So modulus of this is 0 square, 1 square, and this will become 9/4 plus 1/4, 10/4. So square when you do, it will become simply 10/4. So 1 plus 10/4 plus here it will be 1/4 plus 1/4. So it will become basically 12/4 or 3. So the answer is 4. ये बन जाना चाहिए था सबसे बिना कोई मिस्टेक्स के. It is quite easy, right?
Yes, sir.
Yes, sir.
Okay, next one is this. Let W equals Z conjugate plus K1Z plus K2IZ plus lambda times 1 plus I, where K1 and K2 belong to real. Then they are saying let real part of W be equal to 0, be the circle of radius 1 in the first quadrant, touching the line y is equal to 1 and the y-axis. Okay, if the curve imaginary part of W is 0 intersects, this circle is called C. If the curve imaginary part of W intersects C at A and B, then you have to find out 30 times AB square. Again, the point is to try to understand what the question is saying. Let W be this complex number, right?
Yes.
Lambda is also probably some real number only, right? So a real part of W is equal to 0 basically will come out to be some circle apparently. That is what they are saying. Real part of W is equal to 0, equation जो आएगा उससे is becoming a circle of radius 1 in the first quadrant touching the line y is equal to 1 and y axis, right?
Yes, sir.
Okay, so actually with all this information you can possibly say many things about the circle. You can possibly find the equation of the circle without doing complex numbers only, right? Circle C of radius 1 in first quadrant touching the line and the y-axis, right?
Yes, sir.
So if you can get that circle equation, then you can simplify this W part and compare coefficients to find the values of K1, K2 and so on, right?
Yes.
So first think of the coordinate geometry question, which is in part 2. Can you figure out the equation of a circle which has radius 1, touches the line y is equal to 1, and also y-axis, right? So
Yes.
technically it is like a circle like this, right? Touching the line and the y-axis, right?
Center at half comma half.
Radius is 1. So 1 second. If the radius is 1, then center half comma half होगा. Okay.
अच्छा रेडियस 1 है तो सॉरी
Radius 1 है.
ऐसा
तो
नहीं
सर्कल ऐसे टच कर रहा है, रेडियस थोड़ा बड़ा है. It will be like this, right? Something like this. Right?
यस सर
I think it will be here somewhere, no? 1,0 पे होना चाहिए ना सेंटर. समझ में आ रहा है सबको? I hope everyone is understanding. Sikandar, are
सर
you
ये
understanding?
सर ये y इक्वल्स टू 1 के ऊपर भी तो हो सकता है, लाइन के ऊपर।
हाँ, ऊपर भी हो सकता है. ऊपर भी हो सकता है, नीचे भी हो सकता है, right?
अच्छा, ओके ओके।
There are possibility. Okay, it is saying in the first quadrant, so actually नीचे तो नहीं हो सकता है, right?
हाँ वही तो सर।
हाँ, so ऊपर ही होगा, right? तो यहाँ से 1 की दूरी पे और यहाँ से 1, so it
यस
should
सर।
be
1
uh,
comma
2,
1 को
1,2, right? Correct.
यस
1,2 सेंटर होना चाहिए, रेडियस 1 है, तो सर्कल का इक्वेशन तो फुली पता है, राइट?
इक्वल्स टू 1।
This is the equation of the circle. Now all you have to do is simplify this a little bit and find the real part of this complex number, right? Correct?
यस
So how do I simplify? It is pretty easy. Z को x plus y मान लेंगे फिर से, and we will just calculate accordingly. So z is equal to x plus iy. If you assume z conjugate will be x square plus y square plus k1 x plus iy plus k2 I times x plus iy plus lambda 1 plus I. I only care about the terms which don't have an I because I have to calculate real part right now, right? Correct? Actually, I care about both of them because later in the question I have to calculate imaginary also. Correct?
यस सर।
So let's collect all the correct terms. So x square plus y square, you will get a k1x here, and you will get a I square k2y, so minus k2y here, and you will get a plus lambda here, plus I times, then you will get k1y, and here you will get k2x plus lambda here, right? This is my complex number if you understand what I'm doing. Is it
यस
clear?
सर।
So real part of this is 0, is basically the equation x square plus y square plus k1x minus k2y plus lambda equals 0, right? Right.
यस सर
And this is clearly a circle. And now you can say that this is this circle. And this circle equation was x square minus 2x plus 1 plus y square minus 4y plus 4 equal to 1. 1 gets cancelled. You have x square plus y square minus 2x minus 4y plus 4 equal to 0, right? Correct. And since that is equal to this, we get basically K1, K2 and lambda. K1 is -2, K2 is 4, and lambda is 4, right?
सर K2 -4.
क्यों?
अच्छा हाँ हाँ सॉरी सॉरी 4
ऐसा ऐसा गलती करोगे तो नहीं चलेगा। कॉपी करना है ना, बस कंपेयर करना है ना।
हाँ हाँ सर
K1 -2, K2 4, लैम्डा 4। तो यहाँ पे
yes,
दूसरे वाले कर्व का, दूसरा वाला कर्व इज अ लाइन, उसका इक्वेशन डायरेक्टली आ गया अब तो। लाइन इक्वेशन आ गया -2y प्लस 4x plus 4 equals 0, which is basically y is equal to 2x plus 2, right? Correct, no?
yes sir.
And what we have to find now is a simple coordinate geometry part where does this line cut this circle, right? Correct, no?
Yes sir.
So notice that y minus 2 is 2x. So y minus 2 is 2x, यहाँ पे डाल देंगे तो हो जाएगा, I will just create some space here. You have to find the points where the line cuts the circle. So the way to do that is to solve the line with the circle equation. So solve the line. So take the line equation, use that in the circle equation. We'll say y minus 2 is 2x. So here we can put x minus 1 whole square plus y minus 2 2x, so 4x square is equal to 1, which implies x square minus 2x plus 1 plus 4x square equal to 1. So you have 5x square minus 2x equals 0. So x can be 0 or x can be 2 by 5, right? And when x is 0, y is 2. And when x is 2 by 5, y is 4 by 5 plus 2. So 10 by 5 plus 4 by 5. So 14 by 5, right? These are my 2 points of intersection A and B, right? So you get 4 by 25 plus 2 by 14 by 5 minus 2 is again 4 by 5. So you get 16 by 25. So root over this. So 20 by 25. So square it. 20 by 25 comes out multiplied by 30. So you are getting 5, 24, right?
Yes, sir.
Is everyone understanding?
Yes sir.
The complex number part was just simplifying. After that, it's actually a coordinate geometry question. Circle question mostly, right?
Yes, sir.
Okay. So complex numbers have a lot of applications. So that's why we are doing these types of questions also. Also, these are JEE mains questions from previous years. So the next one is, let C be a circle in the complex plane with center Z0 equals half 1 plus 3i and radius r is equal to 1. Let Z1 equals 1 plus I and the complex number Z2 be outside circle C, such that mod of Z1 minus Z0 multiplied by mod of Z2 minus Z0 is equal to 1. If Z0, Z1 and Z2 are collinear, then the smallest value of mod Z2 square is equal to what? Again, think carefully about how to do this question. Think about the geometrical situation. The circle C is a circle in the complex plane. Center is given, radius is given, right? So the center is what? Z0. Z0 is somewhere here, half comma 3/2. I hope everyone understands that a complex number can be represented as a point in the complex plane, right? So this is the center of the circle, radius is 1. So I can draw a circle here. It will be like this, something like this, circle. This is my circle C. Now Z1 and Z2 are 2 points outside the circle. This point is 1, 1, 1. We can easily check whether it is outside or inside. Z2 is outside the circle such that Z1 minus Z0. So distance of this Z1 from the center and distance of Z2 from the center, product of the distances is equal to 1, right? Correct.
After that, we can use parametric equation.
So Z1 and Z2 का distance center से product of those distances is equal to 1. And then they are saying Z0, Z1 and Z2 is collinear, are all collinear. Correct. So basically what can you do? Fine. Actually, first of all, we can calculate this distance directly. There is no issue in this. Mod of Z1 minus Z0. What is Z1 minus Z0? That is 1 plus I minus half minus 3/2I. So this becomes half minus half I, right? So mod of Z1 minus Z0 is equal to root over 1/4 plus 1/4. 1/√2. Correct? Are you understanding?
Yes, yes.
So then Z2 minus Z0 ka mod must be √2, right? Correct.
Yes, sir.
Great. From this, because this was known, we have found this distance. Now let's think about the collinearity part, what he is saying. These three complex numbers are collinear, so they must be lying on the same line, right? Correct?
Yes, sir.
These three complex numbers are collinear, so they lie on the same line. And we know that this distance is 1/√2 and this distance is √2, right?
Yes, sir.
Since they are collinear, we can basically say that this angle is 180 degree, right?
Yes, sir.
And that angle, you should know how to represent angles in complex numbers. So the way to represent the angle is argument of Z2 minus Z0 by Z1 minus Z0, right?
There is answer 17/2.
Smallest value of Z2 square, you have to find mod of Z2 square, smallest value. Answer is not 17/2. So I am saying argument of Z2 minus Z0 by Z1 minus Z0. Argument of Z2 minus Z0 means this line's argument, and Z1 minus Z0 is this like segment's argument. So the difference between the arguments must be pi. So what you can say is the complex number Z2 minus Z0 by Z1 minus Z0 is equal to REI theta. R is the R of this complex number. So that is mod of Z2 minus Z0 by mod of Z1 minus Z0 e power I, and its argument is pi, right?
Yes, sir.
So now mod of Z2 minus Z0 is root 2, and this one is 1 over root 2. So it is root 2 by 1 over root 2. E power I pi is minus 1. So this becomes minus 2. We basically get the equation Z2 minus Z0 by Z1 minus Z0 is equal to minus 2, right? Z2 minus Z0 by Z1 minus Z0 is equal to minus 2. So we wanted to find Z2. So we are getting Z2 is equal to Z0 minus 2 times Z1 minus Z0, right?
Yes, sir.
Yeah, correct. Here it could be plus or minus pi also, right? Minus, no, that doesn't make any difference. Okay. So we are getting this value, and we know Z0, Z2, Z1. So we can actually find the complex number. Right now, one of the values that we are getting is 3Z0 minus 2Z1 is Z2. So if you calculate that, you will get, I think, minus half plus 5 by 2I. And in that case, the modulus is coming out to be 13 by 2. Modulus square. The other case will come when
I
notice,
was also same thing. By mistake, I told 17 by 2.
but this is not the correct answer, because we could have had Z2 on this side also, right? Instead of Z1 here, we could have Z2 here and Z1 here, right?
Yes, sir.
In that case, the sign will change for everything. We would have argument of Z1 minus Z0 by Z2 minus Z0, right? Correct? You will basically end up getting plus or minus 2 here. And when you do the plus 2 condition, you will get the complex number Z2 is 3 by 2 plus half I. In which case the modulus of Z2 square is coming out to be 5 by 2. I will explain. So basically the idea is this. I don't know which side Z2 and Z1 and all are on, right? It is possible that Z1 was this side and Z0 was this side and Z2 was this side, right? Are you understanding what I'm saying? So when I write the argument here, this is what we did earlier. We wrote argument of Z2 minus Z0 by Z1 minus Z0 is equal to pi. But we could also have written like this, argument of Z1 minus Z0 by Z2 minus Z0 is equal to pi. In this case, the complex number will look like this, Z1 minus Z0 by Z2 minus Z0 is equal to 1 over root 2 by root 2 minus 1, right? This case will get minus 1 by 2. So you get minus 2Z1 plus 2Z0 is equal to Z2 minus Z0. So Z2 is coming out to be 3Z0 minus 2Z1. Right?
Yes, sir.
Yes, sir.
So hopefully you should get two different answers. Like you should check it out once yourself also. Should get two different answers.
I use parametric form.
There are obviously other ways to do it also. You can just convert the question to a coordinate geometry question directly, right?
Yes, sir. Like center we had been given, and also,
Circle ka equation in x and y only you can write.
yes, sir.
If you write the circle equation in x and y, it is x minus half whole square plus y minus 3 by 2 whole square is equal to 1. This is my circle. one of the point is 1, 1, Z1, right?
Yes, sir.
1, 1, Z2 is an unknown point, and circle center is obviously half, 3/2, right?
So angle is 3 pi by 4 then. So
You
it is
can say that Z2 is half plus,
plus minus also.
half plus minus R cos theta and so on, right?
Yes, sir.
You can do it by parametric method also, that's also fine. But you should get two possible points for Z2, right?
Yes, sir. Yes, sir.
When you check both the points, then you will guess which one is the smaller one. Okay, please keep revising your complex numbers. We'll do complex number questions only for the next 2-3 sessions at least, till we cover all the theory. We will be discussing the theory through the questions. So whenever required, we'll discuss the relevant theory.
Okay.
You can
Sir,
finish.
after this, can we start PNC after this
Yeah, that's
complex?
fine. Hmm.
Okay.
Okay, right now that's all for now. We'll continue tomorrow. Okay.
Okay. Thank you.
Bye.